Okay, let's look at the stability of the floating body in a better situation. Look at the figure on the left hand side, figure 3.2. You can see there are two forces as we discussed before. The one force is like a W, downward, towards downwards, and the second one like the buoyancy force towards upside. So we can see here they're like these forces, like the W, act at the center of the gravity, like, and we denoted by G, for example. Here, imagine this like the center of the gravity of the pontoon or this body floating uh, in the water, for example. And the situation is that there's no like the tilt, there's no like the wind, wave over the water or the surface water, and we have no tilt, and we can say like that there is a like an even keel for this kind of like a pontoon with the, like the F and W, and they balance each other, and we can say like the, because they're just kind of passing through one line, they are like a collinear. So that's like a situation for the floating body. However, in some cases we might just see the tilt happens or tilt caused because of like the gusty wind, any kind of like the wave in the sea, for example, the natural like the wave might happen, and that cause like the tilting. The tilting cause like this kind of like a collinear is not in place anymore. And for example, we're just going to look at this and analyze what's going on. First of all, the angle of the tilt is created. You can see that the angle of the tilt is created here because of the wave or like the gusty wind, for example. We can see here all the time the the weight of the body passing through the center of the gravity. Okay, so it's like intact. So the way that like the W is acting exactly at the same point. However, the place that the buoyancy force is acting is just moving because the center of the area of the floating body changes. I mean, just let's look at here on the left hand side. The G is the center of the gravity, but the F or the buoyancy force acts at point center of the volume of water displaced, or the center of the gravity of the displaced liquid. That is it here. For example, imagine if this is like the dash line or dash area of the rectangular like the shape is like the volume of the water displaced. The intersection of the diagonals, which is passing through like the point B, we say this is like the center of the gravity of the displaced water, or point B, okay, or the center of the pressure that we're just gonna see the, or the center of the pressure for the buoyancy force. However, once we have like a tilted situation or tilting, we the center of the area of the displaced, or the center of the gravity of the displaced liquid, it's not going to be like that point B. So as you can see intuitively, just going to move to the left hand side, and it's just going to show that one. For example, let's say in this kind of like a trapezoidal, like the center is equal to like a B star, and we're just going to see buoyancy force acting at point like a B star. So in here again, we have like the, we don't have like collinear of the F and W, but we have like a writing couple. Writing couples like the same force because the W and F is completely the same. They are in parallel, but they have like a difference between as much as like there's something like a difference between these two, and we're just gonna convert these two forces to like a moment, or that we can call this kind of like the moment as like a restoring moment or writing couple. Writing couple, imagine this kind of like the force trying to just get back to normal, and try to just get back the like the forces to the normal situation. So this is the situations that we have. So imagine this kind of like the forces trying to just get back to these situations. So that is like the forces, the writing couple. Okay. However, if we're just going to look at the situation, for example, the center of the gravity, for example, or like the weight center of the gravity just move like the upside, because, for example, we have like some larger pieces put in at the top of like the pontoon. The G moves like the going to the upside and becomes higher. And in some cases, the angle of the tilt, if it's increased, so we can see that this kind of like the this moment, which in that case trying to just return the pontoon to the even keel. In that case, you can see here the W is acting on the left hand side in this figure of the buoyancy force, and the moment created, or the couple of forces, is not going to just return the pontoon to the original, or is trying to just overturn the pontoon. So that couple is called overturning couple. So for example, for this figure, that pontoon is working like this one and trying to overturn the pontoon, and the pontoon will be unstable. But however, for a figure 3.3, the pontoon is stable. In this case, the pontoon is unstable, and we're just going to say this pontoon will capsize and overturn, and everybody and everything will be tipped from this kind of the pontoon. So these are the situations that we have. So you need to just bear in mind these situations as well. So, and one more important thing is the metacenter height, or the metacenter points. So how is it calculated? Imagine we have a tilting situation like this one. The intersection of the original BG, or the collinear ones that we have, the extension of that line with the will intersect the vertical line through the point B prime, or the B star. So you can see the intersect of the vertical line through this one and the original BG lines. They intersect at the point that we can call it metacenter. So this point M, the distance of that point until the point center of the gravity G, they call it the GM. Distance GM is very important. It's called the metacentric height. And metacentric height is a very important parameter. Why? Because if the GM is large or long enough, we can say the pontoon is stable enough, or it's the stability is more guaranteed. And as much as the GM decrease, and in the maximum or the worst case scenario, if the M coincides point G, we said the GM is the 0, and we have a natural stability. And in that case, if the pontoon is tilted for whatever the angle of the tilt, will definitely float, and that sort of thing will capsize and overturn. And the situation is that if the M is definitely below G as well, is the same, the pontoon is unstable, and the pontoon will easily overturn if it's the tilted. So that's some of the key factors for the stability of the pontoon.